this. If a polynomial function is divided by x minus c, then the remainder is really f of c, isn't it? Isn't that what we just proved right up there? This is the remainder of x minus c, and this is the value of the function f of c, isn't it? So that's what it says to us. So now we can use synthetic division to evaluate, and you know what it's called? Synthetic substitution. Right? Think about why that would be. We're substituting in here, aren't we? And we're using synthetic division to take the place of that substitution. So now all we have to do is, it says use the remainder theorem, which is synthetic substitution, to evaluate f of x at c. Now when this works best, if it's a small function, sometimes it's faster just to plug it in. But look at the big long function we have there, x to the fourth, x to the third, x to the second, etc. That one really is faster to do, even with your calculator, it's faster to do using synthetic division. So go ahead and use synthetic division, and then we'll check it on our calculator. So let's set this guy up. What goes on the outside? -3. 1, 8, 12, -7, and -14. So we're just going to bring stuff down. And this is how I would like your answer expressed. So that you know that what we've just done really is subbed in. And throw it in your equation editor and hit second calc value and double check and make sure I'm right. And then do number 4 on your own. And double check your work using your calculator. Did I get it right? What'd you get for the answer, Emily? Yeah. Should double check it and make sure you got 11, right? So we can successfully use our calculators as a tool to help us with what we're doing. Any questions on how we do this? Are we good? Thumbs up, thumbs down, thumbs, where are we at here? Good, good, pretty good? Okay. All right, so anybody feel like you need to do a couple more examples, or can we cruise on? Let's look at number 5 just to be on the safe side. Why do you think I want to look at number 5? Probably because there's a chance that you could make a mistake here. If you're setting this up using synthetic division, we know -5 goes out here, but what goes up top? Thank you. This guy right here is what some of you will forget to put in because it's at the end. You have to have every single place filled. So go ahead and work this one out, figure out what it is, and double check it with your calculator. If you ever teach yourself a skill that really comes in handy, knowing how to multiply big numbers in your head is a very good skill to have. I can do this in my head faster than most of you guys can do it on your calculators. Do you know how to multiply big numbers in your head? Do you know what the trick is? Like 5 times 72?
5 times 70, 5 times 2.
Yeah. 350 plus 10 is 360, right? That's how you do it with an abacus. All right, so are we good? Move on? All right, so let's apply this. How does applying it help us? The number of tickets sold at the Oakdale High School football season can be modeled by an equation. Yay us! Where X is the number of games played. It says, using the remainder theorem, find the number of tickets sold. We want the tickets sold during the 7th game of the season. 7th game of the season. So what we're really looking for is f of what? 7. So this is an application we can use this synthetic division for, isn't it? So we're going to put 7 out here. And we're simply going to multiply out. Get 229 tickets. All right, so look at number 10. The distance in feet that a person travels on a snowboard is modeled by an equation. They give you an equation there, d of t, where t is the time in seconds. Use the remainder theorem to find the distance traveled after 1 minute. Anybody want to tell me where the hang-up will be, where the mistake will be made?
You do 60.
Yeah. If you put 1 out here, it's going to be wrong, isn't it? Why? T is in seconds, but we're given 1 minute. So 1 minute, 60 seconds. So we have to put 60 out here. What's mistake number 2 that you're going to make? Yep. Last is 0. 0.6 and 10. And yes, you do have to put 0.6. Times 60 is 36. All right, so 2,760 feet. All right, this applies to what we're doing now. What is the factor theorem? What does the factor theorem says? The factor theorem says if we have a polynomial function, and that polynomial function would be f of x, wouldn't it? That if we want to know it's a factor, then when we plug it in other words, when we do synthetic division, we should get what as a remainder? 0. Okay? So, given, to put it in nice mathematical form, given a polynomial function, f of x, right? Then x minus c is a factor if of, let's do this, of f of x, if and only if f of c equals 0. That's what the factor theorem says. In reality, what the factor theorem is you put it through, you put the factor potential root through or potential solution through using synthetic division, which is effectively synthetic substitution, isn't it? And check to see if you get a remainder of 0. Because you should get a remainder of 0. Think about why that is. All of these points, all of these solutions represents x-intercepts, don't they? And what is the y value of a point on the x-axis? 0. So if we plug in an x value and we get out 0 for the y value, it is an x-intercept, isn't it? If it's an x-intercept, then it's a solution. Do you see how all of those things that you've learned now from the beginning of this class all kind of come together? You've got to understand where we're looking at. Don't just check a box. So now it says, use the factor theorem to determine which one of these guys we're testing for factors is a factor. Check them all. So here we go. So let's do this, and I can show you some shortcuts you can use. Let's start with the first. You want to start with the first one or the second one? Let's start with -1. It's right here. So this guy brings out -1, doesn't it? So we're going to set this up, and we're going to say -1 here. And we're going to go 1, 0, -31, 30. So I got to check this real quick. Bringing it down, I get 1. 1 times -1 is -1. Add, we get -1, +1, -30, +30, and 60. Get a remainder of 60. Is this a factor? No, it isn't, is it? No. All right, so let's check the next one. -5, +5, wouldn't it be? That'll be the big mistake you make, is when you pull it out, and we got to put it through the same thing again, don't we? 1, 0, -31, and 30. Get 5, 25. We get 125. Oh, wait a minute. What did I just do? I just made a mistake. Excuse me. Glad I caught it early. 1, 5, 5, 25. There we go. -6, -30, and 0. Yay. This guy is a factor, isn't it? Now, here's the really cool thing. I still need to see if -6 is a factor. Here's the nice thing I can do. I can take what's left here, because remember, we've just pulled a factor out, haven't we? I don't have to put it back through that original big line. I could just put it through this. And if it's a factor, it should end up as a remainder out of this, shouldn't it? Think about it. We could take that quadratic and factor it out and see if we got that. So all we have to do, once we find a factor with remainder 0, we can take, if we've got more factors to check, we can simply take the reduced line and run it through them. If we find another one, we can reduce it and run it through it again. So let's take -1, or take 1, 5, -6. And what am I going to run through it? -6. Bring down the 1. We get 1. This is -6. We get -1. We get +6 and 0, don't we? So this was also a yes, but you know what else we've just figured out? We figured out we've completely factored this thing. Think about it. We have the factor of x minus 5 that we found here. We have the factor x plus 6 right here. And guess what we have here? That's the last factor, isn't it? If this was cubic, then this is squared. This would be an x squared, wouldn't it? So this would be one step down from that, which would just be x minus 1. So guess what? That's my last factor, isn't it? This is part of the process we're going to use. We're going to use synthetic division a lot to help us figure out whether something is a factor and reduce what we're having to feed all this stuff through. Okay? If we can identify more than one factor, we can keep reducing until we get all the way down to a quadratic where it's easy, or we can keep going from there if we need to. Any questions so far? Let's try another one. So we want to check 2. Negative 2, x minus 2 means we're going to put 2 through, aren't we? 1, negative 6, negative 17, 78, negative 56, and 0. Don't forget the 0 at the end. Get a yes? All right, so now what? Now I can simply take this, and this is how I like to do it, and try the next one. I can feed negative 7 through it, can't I? And even I multiply this one. Yep, 336, excuse me. So, is x plus 7 a factor? No. So I got to go back to this line that I just finished with right here and try the next one. You can't reduce it unless it is a factor. So check that guy and see. Now this guy, we can't go ahead and write out in its fully factored form, can we? Why not? I get 2 of them, but I could have a possibility of how many? So this is a quintic. That means this guy right here would have been a quartic, and this is a what? Cubic. So I've got a cubic right here. Now I could finish up if I wanted to, because this guy would end up being what? X cubed minus 8x squared plus 7x. Guess what I could do? I could pull out an x. I'm left with x squared minus 8x plus 7, which I could then finish up, couldn't I? So it's fully factored form. It has actually 5 different roots, doesn't it? It would have the fully factored form of x minus 2, x plus 4, x minus 7, x minus 1 and then an x in the front here. And that would be a fully factored thing. Now, do you have to do that right now? You're going to have to do that next. You might as well get used to it, right? Because look what it says next. Factoring in what? Finding the zeros. Completely factor the polynomial function. Okay. They give you 1 0, so now you have to finish up. This is a cubic, so should we be able to finish it up? What are we going to get when we put a cubic through? The result's going to be a quadratic, which we ought to be able to factor, shouldn't we? All right. So let's see what we can do with this. What goes in the front? We'll do this one together, and then I'll make you do several on your own. Down 1, -3 here, we get 0, 0, -4, +12, and 0. So it is, isn't it? So now what we have right here is we started out with f of x equals x plus 3 times what? What's left here? X squared minus 4, right? Yes. Which then is a difference of 2 squares, right? So x plus 2. So that's our fully factored form, right? So this is the completely factor part. Remember what I said about you were going to have to get used to writing it in its factored form? So there's my first answer. Then it says what? Well, if you've got the fully factored form, shouldn't you very easily be able to give the zeros? What are my zeros going to be? -3 and plus or minus 2. Sure enough. All right. So why don't you try number 4 on your own, and then let me look at some of these, see which ones I want you to do, because then you don't have to do all of them. Yeah, try number 5, or 4 and 5, and then 6 and 8. You don't have to do 7. So try 4, 5, 6, and 8. And there are the answers to 4, 5, and 6. As you get done, you can check them. Let's see how you do. If you're running into trouble, let me know. I'll be happy to help you. Otherwise, I'm going to sit up here because I don't need to be exposing you to me or me to you any more than necessary. This is a cubic, so now this is a quadratic. So if you write this over here is a quadratic. Okay? No, it's x squared, 1x squared plus x minus 4. Right? What comes out of this? These
since these are the coefficients, these are all the coefficients of these guys, and this is to the third power, these are all the coefficients of a line that is a function that is one step down from that. 1x squared plus 3x minus 4. Yes. Now we got it? Okay.
Put the answers number 8 over to the side so you can see them. And you can check your work. If you get all those right, get started on your homework. You should have time in class today, since it's just homework 6. Cruise through and maybe get it done. The longest part of the process is going to be the factoring. You take the notes for like game. Yeah, finish my stuff first. So just to give you a preview, up to this point we've given you at least one factor. Next lesson is on what if we don't give you a factor to start with? How do you figure out what possible factors are? So that's what we'll add next. So Friday should be fun. Coefficient in front, 2x squared. Plus 7x. Plus 4. All right, so now you crisscross and find your factors and factor by grouping, right? Okay.
7. For 8, I got 3 halves instead of 2/3.
Might be already backwards. My dyslexia might have gotten the best of me. Nope, 2/3. 2x minus 3, 2x plus 3. Oh yeah, it would be 3 halves, wouldn't it? Oh, they made a mistake. Thank you for catching that. So